Welcome to this class. In this session, we are going to do an example on finding center vertices, foci, and equations of asymptotes for a specified hyperbola. So in this case, the hyperbola is y squared minus 4x squared minus 8x minus 4y minus 4 equals to 0. So the first step is to reduce the equation given into standard form so that we can easily read the coordinates of the center and then values of A and B. That will help us now to read the other points as foci and the vertices. So solution. So first, we transform the equation into standard form, i.e., either in the form y minus k squared. Actually, for this case, that should be the case because actually this negative is on the x. In the form, it's not even either, in the form minus x minus h squared over b squared equals to 1. So we bring y terms and x terms together and then take the constant to the right hand side. So we use completing the squares. For both y and x. So we have y squared minus. So we have y squared minus 4x squared minus 8x and then minus 4y and then minus 4 equals to 0. So y squared minus 4y minus 4x squared minus 8x equals to 4. So to complete for y, so b over 2 squared, our b is minus 4, so b over 2 is minus 2, so by squared minus 4y plus minus 2 squared minus, so for this x, let's have x squared and then minus 2x equals to 4 and then plus minus 2 squared. So this step I've done the completing the squares for y variable only. Now for x, so this will give me y minus 2 squared plus minus 4 x squared. So this might be will be minus 1, minus 2, then divided by 2, we get negative 1. Equals 4 plus this will now be 4. And then so I have to add this side. Remember, this is a negative sign here. So I have negative 4 times 1 minus 1 times 2. So I also have to have minus 4 into minus 1 squared. Then that's why, so remember when I open this bracket here, I'll have, just for those who might not be understanding what I'm doing here, negative 4x squared plus minus So so there's a negative here. So in fact, this should be plus. Yeah, this should be plus. When I factor out -4, then this sign must be plus for that one to be correct. So if I have negative here, then this must be plus. So this should also be plus. So I'll have -4 minus 8x and then -4 times 1 squared. So this -4 times 1 squared is a strange term. So I have to balance the right hand side by also having -4 1 squared, so that this and this cancels out, so that the equation has the same original meaning. So I'll have y minus 2 squared minus 4. Now here I'll have now x plus 1 squared equals to now 4 plus 4 minus 4. So this will be y minus 2 squared minus 4x plus 1 squared equals to 4. Then I divide through by 4 by 4 by 4. So I have y minus 2 squared over 4 minus x plus 1 squared over 1 equals to 1. And you see this is the same as y minus 2 squared over 2 squared minus x minus 1 squared divided by 1 square equals to 1. And you see now this is the standard form y minus k over 2 squared minus x minus h squared over 1. This is a squared, then b squared equals to 1. So which tells us that now we can read the values of our h. So this means h is -1, k is 2, a is 2, and b is 1. I remember when the equation of hyperbola is of this form, it means that the transverse axis is parallel to the y-axis. So once immediately you get the standard form of the equation, you should actually have the sketch in your mind. So we are dealing with this case. Where if this is the center, h comma k, then we have this is how the hyperbola looks like. The transverse axis is parallel to the y-axis because the y term is the one that is positive. Now, so therefore center, in this case is C, h comma k, so which will be C has coordinates -1, 2. So those are the coordinates of the center for this given hyperbola. And then from this diagram, this is where we expect to have this way we expect to have our V1, and then our F1 will be here. So remember always distance, so C squared is given by A squared plus B squared, which will be 2 squared plus 1 squared, 4 plus 1, which is 5. So C is √5. So then now, vertices V1, for you to read this coordinate here, so remember this is H, and then this is K. So this will be K plus A this will be K plus C. And then this is V2, this will be K minus A, and then your F2, this will be K minus C. So the V1, we have H, comma, this other point is K plus A. So which will be V1 is -1, comma, K, which is 2, plus A, which is 2. So V1 has coordinates -1, comma 4. V2 is H, comma, so this V2, K minus A. So which will be -1, 2 minus 2, which means V2 will be -1, comma 0. And then F1, this point here, will be H, comma, K plus C, which will be F1, H, which is -1, K is 2, C is √5. And then F2, this will be given by H, comma, K minus C, which will be F2, H is -1, and then 2 minus C is √5. So those are the coordinates of the foci. And asymptotes, remember from our earlier discussion, when the transverse axis is parallel to the y-axis, then the equations of asymptotes are y equals to plus or minus a over b into x minus h plus k. So which means we'll have y equals to plus or minus, our a is given as from this question, a is 2, b is 1. So 2 over 1 into x minus h in this question is -1, k is 2. So minus 1, and then plus k is 2. So we'll have y equals to plus or minus 2 into x plus 1 plus 2. And then we'll have y equals to plus or minus. So I can just say y equals, now if I take the positive one, I have 2 into x plus 1 plus 2. And the other one would be y equals to -2 into x plus 1 plus 2. And so I'll have y equals to 2x plus 2 plus 2. Should be y equals to 2x plus 4. And this other one would be y equals to -2x minus 2 plus 2. So y equals to -2x. For this other one will give us 0. So that is the solution to that given problem. And with the values of the vertices, foci, and the center, and then the equations of the asymptotes, you can always draw the graph if the equation goes further to ask you to sketch the graph of the equation. So thank you.